Okay, good morning to all. Before starting to the presentation, I would like to introduce myself. I am Amey Ket, currently working as a Deputy Executive Engineer in Mahatransco. I've completed my BTech in Electrical Engineering and MBA Operation. And today we will discuss on earthing and its design specifically. For RTC Jesuri and RTC Turnge, I'm very well much aware about the training and all. And I'm also visiting and guest faculty in Solapur in all electrical engineering colleges available in Solapur itself. So I'm very much happy to discuss whatever I know regarding this earthing and design. And specifically as of today is an engineer batch. So we decided to discuss on earthing and specifically about its design, how the design process is. And today we will having the session in the two session. First session we will discuss regarding the earthing and its prerequisites, its details, and the second session we will having its design and its overview. And I will give an assurance after the second session attendance, you will able to at least design on the prima facie basis that how EHV substations are exactly designed in terms of an earthing. So my screen is visible to all. Any feedback in the chat box, please? Yeah, thank you. So we will start. So first of all, yes, I have opened the chat box also. Yeah, thank you for the feedback, Vishal. We will move ahead regarding an earthing. As we know, today's topic is earthing and its design. So before going to any specific point, we will discuss what do we understand by the word earthing. As we are an electrical power system practitioner, as I hope everybody having experience of 5 to 10 years around. So everyone having much aware about earthing and its definition, but still would like to brush up what is meant by an earthing exactly. So anybody would like to give me a feedback on earthing, what it is mean by? What do you understand by an earthing? Anybody in the chat window? What do you understand by the word earthing? Or for example, to a non-technical person, how you will explain earthing means what exactly? One technical issue, my screen sharing is stopped. Again resumed. Yes. Yeah, I got a feedback from Shashi Bhushan. We'll check what he's saying. Yes, Shashi Bhushan, you're right. Still, we'll have one audio visual regarding this earthing. So first we will discuss what do we understand exactly by an earthing in generally. Non-technically, what do we understand earthing? Then we'll move ahead to the earthing specifically for an electrical engineer. Okay, Tushar also diverting unwanted charge to the ground. Yes, Tushar, you're also right. But we will see the points one by one. So first we will have a video regarding this earthing. But you know that the Earth's energy is due. When we make direct Is it audible to all?
And it's free. We all know the sun's energy is crucial for good health. But do you know that the Earth's energy is too? When we make direct contact with the surface of the Earth, our bodies receive a charge of energy that makes us feel better, fast. This is called earthing. You see, throughout history, people were always naturally absorbing the Earth's energy. But in today's world, we live most of our lives inside. And even when we do go outside, we usually wear shoes, which prevent us from connecting. So, of course, we often feel drained and achy, because we go days or even years without ever touching the Earth. But it doesn't have to be this way. You can start receiving the benefits of earthing by going barefoot outside. The more time, the better. This alone can be life-changing, and it's free. And if you love feeling great while earthing outdoors, now you can start earthing indoors too. Simply connect your earthing product into the third hole of an outlet, which directly connects to the existing ground rod of your home. This connection lets you safely and conveniently receive Earth's energy from wherever you are, whether that be working or playing, and especially while you're sleeping. Because while earthing, you'll sleep deeper, feel more refreshed in the morning, and wake up looking terrific. And the best part? Anyone can benefit from this life-changing discovery. It's a no-brainer. Start earthing today to look better, feel better, and sleep better. Guaranteed.
So, just we have seen one visual regarding an earthing. So, as we've seen in the visual, previously, before to the era, every human being is near to the land for the sake of farming. So, eventually and incidentally, we are moving ahead from farming and landing from earthing to the industrialization to the metropolitan city, and we are far away from the earthing. Similarly, in electrical era, we were far away from the earthing, and nowadays we are near to the earthing. So what does it in earthing exactly? So earthing means an electrical connection to the general mass of earth to provide safe passage to fault current, to enable to operate protective devices and provide safety to the person and the equipment. So what do we understand exactly? The earthing means it's an in general electrical connection which is connecting a particularly a equipment to the mass of earth for the sake of reason of to make a good or safe passage to the fault current to enable all the protective gears we are providing on the EHV system for the safety of the person and the safety of the equipment itself. On the screen, at the top right of the corner, you will see the symbol of an earthing. So what it is exactly the representation of that symbol? The symbol itself represents where we connect an earthing to any equipment. That equipment will be ground and the potential whatever having on that particular equipment will be turned to zero step by steps. That's why the particular symbol is showing step by step it is going degrading the potentials and coming down to the zero. So symbol is like this. And for the earthing, in India, we are having one Indian standard 3043 in 1987, reaffirmed in 2006, known as a code of practice for earthing. So the whole IS 3043 focuses on particularly the code of practices for the earthing, what to do and not to do in terms of an earthing. But the IEEE standard 80, which is formed in 2000, focuses on the guide for safety in AC substation grounding. Similarly, this IEEE standard 80, we as a Mahatransco for EHV system for earthing and design, we are referring this IEEE standard 80 for designing our day-to-day activity-oriented earthing grounding, that is earthing mesh. Total will say directly as earthing. We are deriving the particular design in reference to IEEE standard 80, and whatever the code of practice we are dealing, we are referring to the IS standard 3043. Now coming to the importance of earthing. As we know, as we are aware, the importance of the earthing is to save the person working in and around the substation from dangerous electric shock, of course, safety for the person, and to ensure the quick isolation of a fault in point of the protection view. And the last and the very important thing of the earthing is to improve the performance of the power system towards the stability of the power system. So these are the main three highlighted reasons. For that reason, we are doing an earthing and its importance of an earthing. Now coming to the one experiment, since long ago, one scientist named DyEE, he did an experiment on 28 women and 134 men regarding effects of electric current with increasing in magnitude. So what happens if we pass on one particular grade of current to a sake of gravity? What will happen to that human body? So we will have one result of this DyEE's classical experiment. So what happens if we pass on 1 milliampere current from a human body? So it will give a perception, slight tingling effect only. But if you are passing 10.5 milliampere current to 16 milliampere current, what happens? It's a let go current. It will be unpleasant to sustain also. It is much difficult to release the object also. But if you are ranging it to higher one, what happens? It will lead to muscular contraction, can make breathing difficult. It makes unconsciousness, such as cases can respond to resuscitation, and also 60 milliampere to 100 milliampere. It will be a ventricular fibrillation, stoppage of heart, maybe the respiratory problems, or if we are moving ahead and more than 100 milliampere, what happens? It may be a burning effect to the human body, or maybe if we go beyond that, it will be turned to the ashes. So why I have intentionally added this slide, that we must know what happens if earthing is absent, and if we are feeling these type of currents ranging from 1 milliampere to 100 milliampere, what happens to our human body? So on another hand, as we are earlier discussed, the earthing is very much important in the point of safety to the person and safety to the equipment, and also for the system sake also. So moving ahead, we will discuss now the range of tolerable current in the regards of earthing and its expectations. So the range of tolerable current in terms of a human body with reference to design earth mesh, what it will be. So it will be the effect of frequency. Second is effect of magnitude and the duration of the current or the potential. And the last and very much important thing is importance of that high speed fault clearing relay. So depending upon these three categories or these three bullet points, we can easily define the range of tolerable current as already defined by the DyEE. So now coming to one visual analysis of surface potential, what happens if our substation is without earthing, and what happens if our substation is with earthing. So we will have one visual animated graphical representation you are able to see on the screen itself right now. So on the right hand on the screen, you will able to see some color coding visualization. Similarly on the left hand of the screen. But what is the exact difference between two? So I have taken one case analysis, for example, of 220 kV substations. What happens if the earthing is not installed for a 220 kV substations? So what happens to a surface potential? So as you see exactly on the right corner of the screen, the without earth rod, the maximum surface potential feel by that particular field is tuned to, as per the case of 220 kV substations, it's tuned to 6,809 volts. And what happens if we install the earthing system on that same 220 kV substations, so that the surface potential will be reduced to the 50% extent, as you're able to see on the left hand of the screen, which tuned to 3,304 volt of surface potential only. So what exactly is this difference between these two graphical representations? You can easily point out on the right hand of the screen. You will see there are many red peak and yellow peaks are available on the right end of the screen of the corner. Similarly, while after installation of an earthing, you will see the difference on the left hand of the screen. There are less peaks on the red color, less peak on the yellow color, and less peak on the green color. It's maximizing on the focus on the blue, sky blue, and semi blue. So these are the major difference. What happens if we install the earthing in the substations? So before installation of earthing, whatever maybe there is surface potential, that extend to that 50% can be reduced with the help of the earthing in case of surface potential only. Now, as per IS 3043, what happens equipotential counters if a typical grounding grid with and without ground rods. Similarly, without respect to the voltage level of the site, it's a general representation of rise in the surface potential, and the upper end of the screen you will see a proper distribution of equipotential counters with the help of earthing. And if the earthing is if the earthing is not available, so what happens? The particular potential difference may be felt by the particular site, and the potential rise, the surface potential, you're able to see on the second. So here I'm pointing with the red color as a pointer. So here you can easily observe what happens if we install an earthing. There will be equipotential distribution properly, and there is no surface potential rise happening on this part. This is as per 3043 example. But what happens when the earthing is not available, then what happens to the surface potential? This will be the type of rise of potential on the particular site we will observe. We'll move ahead. Before going to any design, we must know a few design philosophies and different types of earthing also. So today, in this first session, we will be discussing prerequisites of the earthing and its design. And the second session, after the lunch, we will discuss the post session, we will discuss the earthing and its design. So first, we will see the different types of earthing. First one is safety and equipment earthing. Second is system earthing, and third is functional earthing. So what do we understand when a safety earthing, as its name itself indicates, the earthing which is to be carried out on the view of safety. So in short, as earthing which is provided for the reason of, for the sake of safety for the equipment and safety for the person, that type of earthing is known as a safety earthing. So what it exactly? Connecting all non-carrying metal part to the earth, known as a safety earthing. So what are the good examples? As we know, CTPT isolator gantries, we are connecting to the earthing for the reason of safety from the shock. Second, to ensuring the safety of equipment from fire or explosive hazard by providing earthing system of adequate current carrying capability, both in magnitude and in duration also, till the protective system clears the fault. And the last one and very important thing is helping the fast operation of an earth fault relay. So what happens, as we are aware, when the testing batch visits to site for the commissioning of any equipment, they do check before commissioning the proper earthing is provided to the equipment or not. So that type of earthing is safety earthing. So all non-carrying current parts are connected to the ground is coming under the category of safety earthing. So now moving towards the next part, the system earthing. As the name itself indicates, the earthing is carried out for the sake of system only. So good example of system earthing is intentional connection of a neutral of a generator or transformer to the earth for control of the circuit voltages. And a good example in our EHV substations, we'll see the connection of an earthing terminal of a CVT or the lightning arrestor. CVT, capacity voltage transformer, and surge arrestor is LA. So that type of earthing is known as a system earthing. In system earthing, we are earthing a live part. For example, neutral of the transformer. For example, CVT. For example, lightning arrestor. So these are the example of system earthing. Now coming to the third part, it is a functional earthing. As itself name again indicates, the earthing carried out for the function of an equipment to enable to function it. So what it exactly means? So a good example of this functional earthing is a tan delta kit. As we are much aware, if the earthing of tan delta kit is removed, the tan delta kit will not operate or will not perform his duty. So when we connect that particular earthing green color crocodile pin to the earth, what happens? then only that particular tan delta kit, that earthing interlock will be passed on, and then the kit will be able to inject the HV to the particular equipment. So functional earthing means what exactly? The earthing for the sake of functioning of any equipment. So it relates to the earthing of an electronic equipment, as we are already discussed in tan delta kit. It minimizes the electromagnetic interference. As we know, previous to the era, many of us suffering that, for example, timing kit or a Megger kit, or for example that CRM kit are not working properly under the bus because of heavy inductions. So what happens to that kit? Due to this electromagnetic interference, that electronic equipments are not able to perform as per pre-design. So they are displaying only one single line, that there are heavy electromagnetic interference or unable to operate. So to avoid that, now in the current era, many of the manufacturers come with the solution of functional earthing to the particular equipment. For example, tan delta kit now coming with the earthing option. CRM kit is coming with the earthing option. Now we can operate all these kit. If it is available with functional earthing, we can operate all these things, all these kits in heavy induction also. So what happens after the functional earthing? It prevents accumulation of static charge on the equipment. Hence, this functional earthing is very much important in terms of functioning of any electronic equipment or any test equipment. So now I have one animated illustration of EHV substation, very in a narrow-minded view. So here there are three types of connections available, as we are earlier discussed: safety earthing or equipment earthing, then system earthing, and third one is a functional earthing. Now I would like to throw one question to all. Are you able to identify the cases? I will ask you one question. Now in the center of the screen, you are able to see one equipment. This equipment is connected to earth with the help of this riser. So this equipment is properly earthed. Now, so the way of earthing is carried out to this equipment. It is coming under which category? Is it a safety earthing? Is it a system earthing? Or is it a functional earthing? Anybody in the chat box? Yes, I got a feedback from Shashi Bhushan. He's saying it's a safety earthing. Correct, Shashi, you're right. It's a safety or equipment earthing. Now, second question I would like to ask. Now you can see on the top of these gantries, this earth wire is running, and this earth wire is properly connected to the earth of the substation with the earthing mesh. So the earthing of this shield wire coming under which category? Is it a safety earthing? Is it a system earthing? Or is it a functional earthing? Anybody? Again, the reply from Shashi Bhushan itself system. I think the rest of the participants are a bit confused about this. Anyone else apart from Shashi Bhushan? Yes, Tushar. Tushar is saying it's a safety. Okay. Anyone else? Yes, Vijayaraj Gadge is replying it's system. My dear friend, it is example of system earthing, because the shield wire is connected to the ground with respect to directly grounding whatever the unwanted charges coming onto this shield wire by the means of fault, by the means of then a particular, we will say, lightning stroke. So it will carry a current carrying part. So it's an example of system earthing. Now the last one I would like to ask. This substation gantry is connected to the earth. So it is coming under which category? It is system, functional, or safety? Shashi Bhushan again, it's safety. Okay, anyone else? I need a feedback from your end, so I will able to have a good interaction. As we are aware, due to Corona pandemic, we are running this training on live. So I need a feedback. So your feedback is very much important for me to be in the atmosphere of the training. So I am able to deliver you as much as I have. Oh yeah, I got one more feedback from Shraddha. Shraddha saying it's safety. Prashant Kumar again, it's safety. Yes, I much appreciate the responses from all. It's Swapnali Bhosle saying safety. Yes, there are three categories we have earlier discussed: system earthing, functional earthing, and the safety earthing. In the particular animated screen, you are able to see only two examples: safety or equipment earthing and the system earthing. Functional earthing is missing in this screen, as functional earthing is specifically relating to a particular functioning of any equipment, as we have discussed already. The example is tan delta kit. So we'll move ahead. We'll move ahead with the screen. Just a moment, little bit. So coming to the next screen, the different types of earthing. As already we discussed, the different types of earthing, the way of connection we already discussed. We discussed that system, safety, functional, and all the regards, which is a way of connection of particular thing to the earth. That is a way of connections. That type of different types we discussed already. Now we are discussing the different types of earthing, the way of doing of earthing. So there are three types, as we know: pipe type earthing, plate type earthing, and third one is a counterpoise earthing. So coming to pipe type earthing, as we know, as we are currently working in the EHV field, pipe type earthing in the MSTCL, we are having 3-meter galvanized iron pipe. Particularly in the bookish style, we are using a perforated pipe, but in the practical things, we are not using the perforated pipe. We are using only 3-meter GI, that is galvanized iron pipe for the pipe earthing. 3-meter digging, and we are making a charcoal short layers. Depending on that, pipe earthing is ready. I'm covering in a way of very short manner, because we know all these things. I am today here to discuss the things we need to discuss, which is totally depend on our bread and butter. Means when I was in my induction, that time, I don't want to blame anyone, but when I was in my induction, that time, the earthing was covered in the way of bookish style. I felt like we are again in engineering, we are reading a bookish thing. But as we are now in the practical scenario, we are working as a professional. So the things to be covered in the point of professional languages and the professional way of expectation. That is, whatever the things we need in the day-to-day routine, that we need to cover first. So I'm focusing today on that day-to-day need first. So moving again to pipe type of earthing, to the particular transmission tower, that we will say a leg earthing with the help of a pipe electrode. Similarly, the 3-meter of pipe we are using as galvanized iron. Similarly, for each and every third tower, we are making an earth. Now moving ahead to the plate earthing, as we know, with the help of plate earthing, that is copper plate, we are buried in the ground of 600 by 600 into 8.30 plate, or 3.5 mm square copper plate we are using, and a proper arrangement is made for 3-meter, that is 10 feet deep into the ground. We are burying this copper plate, making watering arrangement. We are connecting electrical connection to this and making a mesh with the plate. Now, would like to throw one question amongst you, that as we know, as we are aware, in our EHV substation, we are dealing with a pipe type of earthing. And similarly, in the domestic use, in our residential case, we are using a plate earthing. So why do we are using a plate earthing in the residential case, and why do we are not using a plate earthing in EHV case? Anybody would like to give me feedback? Any feedback in the chat box? Shall I repeat my question? Okay. My question is, as we know aware that EHV substation, we are dealing with pipe type of earthing. Similarly, in residential, we are using plate type of earthing. So why we are using plate type of earthing in the domestic case, and why do we are going for pipe type of earthing in industrial grade? So I got feedback from Shashi again. So Shashi Bhushan saying the pipe earthing has more surface area. Okay. Vishal Gaikwad is saying less potential for residential. Okay. Yash Yadav saying voltage difference in domestic and EHV. Voltage difference. Okay. Residential more current carrying capacity. Okay. you're wondering nearby the point. Anybody would like to focus the main point I would like to underline? Anybody amongst you from the 21 participants that currently listening me? Any more feedback? Okay, I will modify my question again. Can we use this plate type of earthing in our EHV substation? And why so? And why not? The reason behind also. Shashi is saying yes, we can't. Okay, so what will be the reason? What is the main underlying criteria that because of this criteria, I can't use plate earthing in my EHV substation, and I don't want to use this pipe earthing in my residential case? Okay, I got a feedback from Vijayaraj Gadge saying fault current and resistance. Yes, you're correct, Vijayaraj. Tushar Valmi, you're also right, it's cost. So I would like to summarize these all inputs given by you. So what happens in the case of, again Shashi is saying something, pipe has more area of creating equipotential. Okay, we'll coming to that point. So what will be that particular line I can draw, and I can say this category to be done under the pipe earthing and this category to be done under the plate earthing. So what will be that main underlying criteria? So that main underlying criteria is the fault current, not the voltage. Someone said earlier the voltage. So my dear friend, voltage is not the criteria for the selection of type of earthing. It's the fault current criteria for the selection of an earthing. So how we can decide where do we make a plate earthing and where do we go for the pipe? It's the basis of the fault current. While we are comparing the residential or domestic case with the industrial or EHV substation case, the major difference is there is a difference in the fault current. So as in the case of domestic, we will know, we are very much aware that domestic fault current is much about 1 kiloampere to 2 kiloampere, not more than that. But in the case of EHV substation, that fault current is leading to up to 10 kiloampere to 12 kiloampere in the ranges. So what happens if the fault current goes on improving? What happens? We need to improve that earthing electrode cross-sectional area. So what happens if we install plate earthing in the substations? So we do require a size of plate such a way that the size of the plate will be bigger than the size of the substation. So it will be another techno-commercial solution. So we will not going the plate earthing to the EHV substations, which will not be a cost-effective solution. We are going particularly to the sake of that fault current. On that basis, a cost-effective and techno-commercial point of view, we are going pipe earthing in EHV grade and plate earthing in terms of domestic case. Yeah, I got one question from Yash Wadhav. Why not on the basis of the voltage? My dear friend, the earthing is totally based on the current. There is no view of voltage in the case while we are doing an earthing and the mesh we are connecting. Now, I will answer very briefly with respect to your question in the second session as we are covering the design part. On that design part, why do we consider only the fault current and why do we not considering the voltage for the sake of selection of type of earthing and the sake of selection of cross-section area of the material? Okay, so we'll keep this point in the pocket. We will reopen the point in the second session, that is the design of earthing. Okay, yes, please keep in the mind. Now moving ahead, coming to the last one, that is very important thing is the counterpoise earthing. As we know, we are very much aware about the pipe type earthing and the plate type earthing. But the counterpoise earthing is specifically done for the EHV transmission towers. In the counterpoise earthing, what we do exactly, all the four legs of the transmission tower are earthed with the help of, in the respect of their voltage levels. So what happens if the tower is up to the level of 220 kV and below? So we will use 7 by 3.5 mm size of galvanized steel stranded wire for the depth of 450 mm and for the length of 15 meter for every leg of the transmission tower. And for 400 kV towers, we will select the size of galvanized steel stranded wire of 7 by 3.66 mm and for the depth of 1000 mm for the length of 25 meter. So for if you are taking the case of 400 kV tower, So for the 4 legs, we will throughoutly run the 25-meter this galvanized wire for each and individual leg of the transmission tower. So what is the main expected need of the counterpoise earthing is to avoid these transient faults occasionally coming on the transmission lines. So many of the people are from O&M, they do aware that many of the time the transmission lines are tripped on transient faults. So we can analyze that particular fault, which is 99% times it is totally because of poor earthing of that particular tower. So we need to check properly the earthing of the tower. So those are from the maintenance department or line department. They are requested to check the particular tower earthing very well and very keenly. And this counterpoise earthing is very much important in day-to-day life of the EHV substation. And very much important thing for the project division people who are attending this session, the counterpoise earthing, what happens due to the deadline of the project, what happens, the contractor or the particular vendor try to wind up the counterpoise earthing very fastly. So they are forget or they are ignoring to unbundle that particular galvanized steel stranded coil, and they will directly dig it as it is with the earth. So this is very much dangerous than not doing any earthing, but doing the improper earthing is very, very much dangerous in the case of counterpoise earthing. What happens? So I have one case study regarding this counterpoise earthing that we are covering later on the presentations. We'll move ahead. Now coming to the second option available in this current era, that is a chemical copper bonding earthing, as we use this word in day-to-day style. This is coming to the fast electrode. The fast electrode is, Shashi, as you said that counterpoise earthing you are expecting once more. So for this case, I am already added one slide regarding this transient fault cases of transmission line due to improper earthing. In that slide, we will properly discuss the counterpoise earthing again. Okay. So coming to this chemical copper bonding earthing, that is fast electrode. So as we know, we are aware pipe type earthing, plate type earthing, counterpoise earthing, and blah blah. But now the era is of 2020. We are having one more very ready-made packet style. Like for example, we are having a Maggie, a 2-minute Maggie, open it and ready and eat it. Kind of solution is available in the market. It is a fast electrode. So what it is exactly a fast electrode? We'll have one visual. Then we will discuss exactly what do we understand by chemical copper bonding.
JMVL PS Limited, leading the nation towards electrical safety.
Hello. Today I'm going to tell you about earthing system. We all are surrounded by an electrical system. Earthing is very important in any electrical installation, and the presence of an earth connection is simply a safety device. The main objective of an earthing system is to ensure safety of life and property from hazards of electric shock and electric fires. It also protects structures and sensitive equipments with unplanned contact with live conductors. Today, due to lack of information and awareness, we mostly use conventional earthing of salt and charcoal solution, which has its own demerits. However, with time, we have more advanced and globally accepted earthing system available in the market known as copper bonded rods, which has overcome the demerits of conventional earthing. Let's understand how copper bonded rods overcame the demerits of conventional earthing. Material of construction. Conventional earthing is made up of cast iron pipe. As we know, iron is considered as poor conductor of electricity that hampers the flow of current and provides low conductivity. Chemical, on the other hand, copper bonded rods are made up of steel rods with copper coating. Copper is considered as a good conductor of electricity, which allows smooth flow of current and enhances conductivity. Corrosion. Conventional earthing is prone to faster corrosion due to direct contact with salt, as it is known to be a corrosive electrolyte, which rusted or corrodes an earthing early and increases ohmic value. Chemical, whereas in chemical earthing, we use chemical compound to protect an earthing rod from direct contact with soil by forming an unsolvable gel protective layer, which maintains moisture in the soil and reduces ohmic value at desirable level. Maintenance replacement. Conventional earthing seeks frequent maintenance, as you need to pour water at regular intervals. And the solution of salt and charcoal get washed away with time, which reduces the lifespan of an earthing, hence results in early replacement. Chemical, as compared, chemical earthing is more durable with the use of an ultra-modern technique, which provides a good lifespan to earthing, without any need to have routine maintenance. Chemical earthing is a cost-effective solution, as it offers long-lasting life to an earthing more than 15 years. Earth-enhancing compound in conventional earthing system. In conventional earthing system to enhance the earth conductivity, we use salt and charcoal solution, but we are unaware of the fact that salt is considered as a corrosive element, which corrodes the earth pipe early. As the salt charcoal gets washed away over a period of time, that decreases earth conductivity. Earth-enhancing compound in copper-bonded rods earthing system. In copper-bonded rods earthing system, we are using lead-free chemical compound, made up of natural formula that maintains moisture around the earth rod, enables soil to provide better conductivity. The compound turns into unsolvable jelly, that maintains earth resistivity without any damaging effects to the rods. Standards and approvals for conventional earthing system. Conventional earthing system is not approved by any international body yet, and there are no fixed standards or specifications of using conventional earthing. Standards and approvals for chemical earthing system. Chemical, unlike wise copper-bonded rods, are approved and accepted by international bodies like UL, CPRI and IEEE. These rods are made as per the required specifications. Installations of conventional earthing system. Installation procedure of conventional earthing system demand more time and money, and it is full of hassles. Installations of copper-bonded rods earthing system. Installation procedure of copper-bonded rod earthing system is less time-taking and cost-effective.
So it is about the particular product demonstration by a particular company, and they are saying that other than this, there is no approved things available in the market, but it's a false representation by the company. As per IS 3043, that pipe earthing is accepted widely by that IS, that is Indian standard, and somewhere in IEEE standard 80, it is already mentioned that pipe type earthing and the plate type earthing are accepted, but not that as per that they are effective comparing to this type of chemical earthing specifically. So now we will discuss what will be the step if we want to replace the existing pipe type of earthing with the help of this fast electrode or chemical copper bonding electrodes. So what will be the step of installation in terms of chemical copper bonding? As we are much aware about the conventional one, the procedure we know what exactly happening on the site. But what if we are going for the fast electrode? So what will be the steps for the earthing? We will see. Discussed, it will be like a ready-made Maggie packet. We just need to dig it particular for 3 meters, and we need to install that copper bonding rod, and we need to pour that in that particular well, and we need to make the electrical connection simple as we seen on the video. That's very simple. Now, the question comes in the mind, why do we are not preferring this chemical copper bonding earthing and fast electrode? I think someone audio is available. Will you please mute? Someone from the participants? Yes, Uma Shankar, will you please mute? Yeah, thank you. Thank you, Uma Shankar. Now, coming to this chemical copper bonding, as we are earlier discussing, why we are not using an MSTCL. So, irrespective of this manufacturer, the type of fast electrode earlier we used in this MSTCL, I don't like to highlight the name of the substation. Itself in the Solapur, we used this fast electrode in one substation. So what happens after a few days, for the sake of time of installation, they have given 3 years of warranty for that particular equipment. But after 1.5 years, that copper bonded rod, that fast electrode is not working that much as expected from them. So what happens after few times, that is after 1.5 years, we removed all fast electrode from the sites and we installed the conventional one. So what happens exactly? As we know, as in the case of Maharashtra, as a case of Mahatransport, we are a government undertaking company. So we need a techno-commercial, cost-effective solutions. So as compared to these 2 points, what will be the good one? Of course, the conventional is good one. That's why we are running, as in the era itself, with the conventional type of earthing, that is a pipe type of earthing. The reason is it's a cost-effective. First one, it's lifelong. It's chemically rugged, mechanically rugged, and very much in the case of lifespan will be more than 25 years. So, case of only if we would like to highlight the point of life case. So the fast electrode having the life of, as manufacturer itself highlights it up to 3 years. So we will not able to go for each and every 3 years. We don't wish to uninstall the earthing and again we need to commission it. So we are not going for this chemical copper bonding. But few substation itself in MSTCL, in many of the turnkey-based substations, the commissioned earlier in 2010, a few of them are currently running with this chemical copper bonding. So many of them are facing currently the earthing issues. So again, our corporate office suggested them to replace them with the conventional earthing. So moving ahead. Now coming to the material used in the earthing. As I already discussed in the first session, we will discuss the prerequisite of earthing and its design. So very important thing is the material used in the earthing. What type of material, on what criteria or on what basis we need to use it. So what is the main thing of selection of material for the earthing? Yes, that Yash, already you were asking regarding why it is not based on the voltage. So for your question exactly, this will be one of the answer from my bucket. So selection of material for the earthing will be based on this following criteria. So it will be specifically first, should we have a very high conductivity. So which is very important thing, the current, that fault current. Now coming to, it should have a high fusing temperature to withstand large fault currents till the fault is to clear. Now I would like to ask one more question to you. As we know, we are running an EHV system. We need to install earthing such a way that it will withstand up to a high fusing temperature to withstand a large fault current. So anybody would like to hit the chat box. What is the fault level of MSTCL? Anybody in the chat window? What is the fault level of the MSTCL? Anybody in the chat window? Fault level of MSTCL. The fault level is very much important while designing any substation earthing. So first of all, we must know what it will be. Yeah, Vishal saying 50 kA. Okay, anybody else? Anybody else? Is Vishal saying right? It's 50 kA. Anybody among from 24 participants? Come on, give me the feedback fast. If you don't know, say don't know. If you do know, yes, say this will be figure. Okay, Prashant Kumar saying it's 40 kA. Shashi is saying 40 kA. Okay. Pratibha saying 30K, okay. Okay, my dear friend, as far as, yeah, Swapnal is saying 40K, Jayashree again saying 40K. Yeah, my dear friends, as far as MSTCL latest earlier declaration by the corporate office, the fault level of MSTCL is 40 KA. And that 40 KA we are taking as a reference for design of earthing plus reference for the particular switchgear we are selecting from the OEM. For example, if you are selecting any circuit breaker, for a circuit breaker, OEM will ask us what will be your fault level, what you want. So that time we need to define. So please go and check your equipment. Every equipment is noted as 40 KA fault level. So coming to the next point, the material selected for earthing should have a mechanically rugged, and very important thing is it must function well where exposed to the corrosive environment. As do we know, many of our MSTCL substations are situated far away from the city, or sometimes they are situated in the industrial areas. So there are many cumbersome situations for the substations to maintain a proper earthing. So in that time also, what happens due to the corrosive style of the or the corrosive nature of that particular soil, or due to environment, what happens? Our electrodes or earthing mesh or pipe type electrodes may get rusted, and earthing may be deviated from the expected value we are expecting from the design. So these are the 4 points we must keep in the note while selecting the conductor for the earthing. Now, moving to the next slide, the selection of material for earthing. As we know, we are having very well aware, very popular two options, that is copper and aluminum. So what happens if we use a copper? What happens if we use aluminum? As we know, as on point of, in the commercial manner, both are expensive for us, but still we will check what happens if we use it. So if we use a copper instead of our regular one, so what happens? As we know, copper has very high conductivity, but it's corrosion resistant, but it forms a galvanic cell with respect to the metal buried in the vicinity and corrodes them. So what happens? Copper corrodes the relative materials. But in case of aluminum, what happens? Aluminum, prone to corrosion in some soils, corroded surface has high resistance, it's anodic to steel and other metals, and what happens? It sacrifices itself. So copper corrode others, aluminum sacrifices itself. But in a techno-commercial point of view, as in the cost-effective options, copper and aluminum will not be a good selection for us. So what will be the good selection? So good selection is, of course, the mild steel. That is MS, we are saying. Mild steels corrodes relatively faster as compared to copper, does not corrode other steel pipe conduit laid underground to the extent of the copper that copper does. Cost beneficial even after increasing cross-sectional area to account for corrosion. The very much important thing, that cost beneficial even after increasing the cross-section area. So we have selected the mild steel. This is the main highlighted points. Now coming to the material for earth electrode, that is for pipe type earthing, the pipe is made of particular material. So what will be the selecting criteria? So that will be again having high fusing withstand capability, temperature in terms of fault current, in terms of cost effectiveness, in terms of mechanical properties, in terms of chemical properties, and of course in terms of conductivity also. So for ordinary soil, copper, CI, and MS can be the option. But if soil is prone to excessive corrosion, copper or GI electrode we are going. So throughout the Maharashtra, we are using the GI type of pipe for earthing. In DC system, only copper we use as a corrosion due to electrolyte action takes place for the other metal in the DC system. Now coming to the next point, the choice of material and the size of earth mat of the conductor. So how do we identify what type of cross-sectional of material we must use for our substation? So a very narrow-minded or very narrowly derived formula we are discussing here. The cross-section of the MS conductor we are using currently, it totally depends on two factors. The first factor is the fault current and the fault clearing time. So again, yes, you need to concentrate on the point Here, the fault current is very much important while selecting a material, not the voltage level. Okay. So what it will be for the welded joints, it will be coming with the coefficient of 12.5, and if with the bolted joints, it will be coming to the 15.8 of coefficient. So major thing I would like to highlight, what are the main points for the selection of material is the fault current and the fault clearing time. Means how much time or how much of extent that material can withstand this much of current with a particular conditions of the sites. So what happens if the material and the sites, we need to balance these two also. So how we need to balance material and the site? Suitable corrosion shall be made to this cross-sectional area by providing a proper safety allowance for the corrosion as below. So what happens if the selected site is having very chemically prone in terms of corrosive view? So we need to add some safety factors. So what will be the thumb rule for that? If the resistivity rho will be less than 100 ohm per meter, then no safety factor added. There is no need of adding. But if it is going below to that, so we need to add 50% for this type of band and 30% for the rho to be less than 25 ohm per meter. So this is a thumb rule for selection of the material. But these all the things we are properly taking care in the second session of design. So now coming to the material resistivity chart, I intentionally added this chart that we must know what happens to each and individual if we select any material. So as we know, silver is a good conductor, is 1.5 into 10 raised to minus 8. And the very good cases of gold also, it's 2 into 10 raised to minus 8. Coming to the iron, it's 9 into 10 raised to minus 8. Coming to copper, again, the pure copper, it's 1.2 into 10 raised to minus 8. The combination of copper coming to 1.6 into 10 raised to minus 8. So these type of material resistivity options available. So apart from this, why we are not going for silver, copper, gold, aluminum and all? Because we need to highlight many of the things as we are discussed already for the selection of material in terms of earthing. So for a cost-effective, cost-beneficial point of view, we have selected galvanized iron. And one more thing I would like to highlight, the chemically clean water having resistivity of 25 into 10 raised to 4, plus 4, not minus 4. The distilled water having resistivity of 5000 ohm meter. So this type of resistivity responses from the type of materials available. Now we will move ahead again. Now we are coming to the design philosophy. Before going to design, we need to aware these 4 potentials. What are these 4 potentials? First one is step potential, second is touch potential, third is transfer potential, and fourth is a mesh potential. So these potential, indirectly we need to maintain a balance such a way that the earthing design will be a for yes, I got a feedback from Zoom itself, so I'm asking. Yeah, now I reconnected again. Now am I visual to all? I think it's connected. Yes, Sashi is giving feedback. Thanks, Sashi, for your prompt response. Now coming to step potential, touch potential, and transfer and mesh potential. So what happens exactly for a successful earth design? We must know the proper balance of these potential, and for balancing these potential, we must know what it is exactly. So we will discuss what do we understand by this step potential. As we know, we are wandering in the substation for substation activity. So if we are walking in the substation or we are standing in the substation, what happens? We are standing on 2 legs. Of course, we are human beings, we are having 2 legs. Of course, itself we are standing on 2 legs. Still, in the sake of this step potential, I would like to take one example. As you are able to visualize the person standing on the screen, the two legs centered on the ground, or we'll say on the side. So what exactly this step potential means? When we are standing in the substations, what is the potential difference felt by our two legs in our EHV substation? So the potential difference seen by these two legs of human body is known as step potential. So what exactly is step potential? Step potential difference is shunted by the human body between two accessible points, between these two accessible points on the ground, separated by a distance of one space assumed to be equal to 1 meter. Assumed to be equal to 1 meter. Now, Vamsi, will you please mute your audio? Yeah, thank you. Now, coming to the example of the step potential, what happens if we are not able to balance the step potential? What happens on the side? So again, I have taken one illustration of 220 kV substation. On right of the screen, this portion, you are able to see my pointer. This portion is without earthing rod, means without balancing the step potential. So what happens to 220 kV substation if the earthing is absent? So the step potential felt by a human body is coming to 1858 volt. It's a case analysis. So the value is coming like this, 1858. So this type of potential difference you must feel, or you may feel on your side if earthing is absent, which is in the regards of step potential only. But if we install a proper earthing as a sake of step potential balancing, what happens? That step potential will come down to the extent of 5,908 volt. 598 volt. So what will be the reduction? So it's roughly 1/3 reduction in the step potential. So how we balance? We will understand the reduction of this step potentials in the design section also. I'm giving you one prima facie highlights of this step potential. So we are covering the case of step potential means what exactly, how it represents, and what happens if earthing is there and if earthing is absent to the step potential. Now coming to next slide, touch potential. Yes, touch potential. As we know, in the substation, we need to make many activity which is regarding to a touch to the equipment. For example, taking a reading with WTI, OTI meters, checking the MB and all, checking any gantry and all, climbing on any equipment and all. So that time we need to make a touch to an equipment. So that time, for example, as we are seeing in presentation, if we are touching to the WTI, OTI box of the transformer, we need to touch by one hand, and there is one touch to the ground. So what will the potential difference feel between these two touch? One touch by hand and second touch by the feet of this human body. What will be the potential difference feel by this human body because of these two touches? That potential difference is known as a touch potential. So the touch potential is the difference between a point on the ground and the point on an object like to carry a fault current, example frame of any equipment, which can be a touch by a person. So this is a touch potential felt by any human body. So if we take an illustration on a 3D plot graph, so what happens if a 220 kV substation is without earthing? So what happens to this touch potential? Touch potential will be 5,171. You will see an illustration on the right side of the corner. And what happens if you install earthing and we balance the touch potential? So the touch potential will be reduced again to the 1/5 of the original one. So it is coming down to 1,527. So in the color coding, you will see able to see the difference. Here there are many red color and yellow color picks are available in the picture, and very few blue and sky blue options are available. So the left hand side of the corner, we will be able to see there are less red pick, yellow pick, but maximum green, yellow and sky blue options are available. So this represented the touch potential distribution among the particular mesh or the particular earthing grid. So what it is exactly and why I'm showing these type of color coding illustrations. So at end of this designing section, I'm giving you one virtual hands-on. I'm highlighting, I'm giving you a virtual hands-on on one designing software. Through that, you're able to see how these plots are plotted on the screen. So from that case study, I have just imported the files and giving you an example relating to the theoretical explanation and the pictorial representation of step potential and touch potential. What happens exactly on the human body behavior and performance, what happens to the particular circuit point of view, and what happens to the particularly on touch potential or step potential in terms of 3D plot potential distribution in terms of an earthing mesh. So moving ahead. Yeah, some delay in the selection. Just wait for a while. We will be moving to the next slide then. Yes. Now the second slide, as we discussed already, step potential and touch potential. In the substation, as you are able to visualize, these type of activity we are doing day to day. For example, working on any equipment, we are moving some equipments overhead, on shoulder, on ground level. Many times we need to touch the equipment. Many times we need to make any readings. That time we need to touch, as I'm highlighting with the pointer. Sometimes we need to walk in the substation. Sometimes we need to touch two different equipments. So what happens? We know physically we are touching, we are walking, but electrically there is a potential transfer. So what potential transfer? Able to see a particular potential, surface potential profile below to these activities. So what happens if we make a movement? So what exactly it's movements? When we are walking with a particular any kind of object carrying on the body, so what happens? We are unknowingly touching any equipment or any object in the substation. That time, what we are doing, we are transferring the potential. What we are doing, that time, we are transferring the potentials. Here, we are transferring the potential from our own body to the equipment and equipment to our own body. Similarly, while touching to any equipment, again, we are making a disturbances to the mesh potentials. Again, we are touching to any equipment with two touches. That will be a touch potential, as we already discussed. And walking in the substations, we are disturbing the potential in terms of two legs. That will be a step potential. And when we are touching two different equipments, we are making a metal to metal touch potential transfer. So these things we are unknowingly we are doing. So now you see what kind of these things, many activity we are doing in the substations. Yeah, one question from Shashi, we will take it. So saying, if there is a transfer of potential, then why not we shock? Yes, it's a good question, Shashi. Why we are not shocked? Its reason is, I will give you in very short, it's because of the design of the earthing. We design in such a way that the transfer of potential will be minimized to such extent that we will not able to feel that potential. So we will cover all these points, and your question also in the second session while we are taking a case study of a design. In second session, I am adding one case study for 220 kV Vairak substation, how the layout is identified, how the layout is approved, and how corporate office is giving exactly approval to the design, and what is the step-by-step steps in the designing and earthing, and why do we are not getting a shock because of these all the potential transfers. We will be handling this point in second session of today's training. Okay, Shashi? So coming to mesh potential, as we know, mesh potential is a maximum touch potential within a mesh of the grid, and transfer potential is means a special case of touch potential where a potential transferred into and out of the substation. For example, metal to metal, as we are seeing on the screen, it is an example of transfer potential. And similarly, a man working with the ladder, it's also a case of transfer potential. If you are standing near to the mesh, standing near to the fencing of the substation, so similarly, what we are doing, we are transferring the potential from inside of the substation to the outside of the mesh. So this is also the case of mesh potential and transfer potential. We'll move ahead. Now, coming to specifically step and touch, very important thing, step and touch is very much important in the case of while we are designing any substation. So what we are doing here, we are deriving a coefficients of step potential and touch potential such a way that we can highlight what happens to the touch and what happens to the step. So here I have taken one case that you are able to see on the screen. I will initiate the pointer. Yes. First, we will see the step potential. If we are standing on the substations, so we are standing with the two legs. So our human body resistance, that particular gravel resistance, earth resistance, and total resistance will make an electrical circuit, as you are able to visualize in this case. So some potential difference, that potential difference will be V3 minus V4 for an illustration basis only, so that human body will feel. So if we need to conclude this type of behavior in terms of electrical circuit analysis theory point of, so what it will be RB plus, it will be RB plus 2 RF. RB will be the body resistance and RF will be the resistance of the soil. So how we will define the RF? So RF will be the resistance of the soil will be considered in terms of coefficient will be 3 rho. So RB plus 2 into 3 rho, it will be tuned to RB plus 6 rho, and RB, a human body in generally as per the Dalziel's experiments, the total coefficients will be tuned to a standard set of analysis. As we know, a substation will have approach for a human that will be a male or maybe a female. All human body will be a two-leg body. All human having ranging of weight from 0 kg to 100 kg, and nobody will come in the tons or in the pounds. So depending upon that, the designer conclude the human body resistance will be 1000 in the mathematical derivation. So it will be coming to 1000 plus 6 rho. So this electrical circuit will be, if we want to represent this electrical circuit in terms of soil resistivity with some constant coefficient which is relating to the step potential, so it will be coming to, so if I want to conclude this circuit, it will be step potential would be equal to 1000 plus 6 times rho. Similarly, for the touch potential, it will tune to 1000 plus 1.5 times rho. So my dear friends, try to analyze the difference of coefficients in terms of rho. In the case of step potential, it is coming as 6, and in terms of touch, it is coming as 1.5. Keep in mind this 6 times rho and 1.5 rho. We will discuss this 6 times rho and 1.5 times rho in the design. This will help us to analyze the design. Okay, so we have maintained the prerequisites and we will move ahead. Now, what happens if we install a proper earthing in the substation, but the vertical and horizontal earthing conductor or that earthing MS flats are non-uniformly spaced? So what happens? So what happens? There are ununiformly spaced conductors. So what happens to the potential differences? So you are able to see this is not uniformly spaced. Look at the space over here. Look at the space over here. Look at the space over here. So it's not properly uniformly equispaced. It's ununiform. So what happens to the touch potential? What happens? We will see. It is coming as the graphical representation of the voltage in terms of red and yellow. So what represented this yellow and red? That it's showing its improper distribution of the potentials available on this earth mesh. So what if we place this horizontal and this vertical earthing conductors equispaced? So what happens in terms of color coding? We will see. So this will be the result. If we space the conductors equispaced, so here each and every horizontal and vertical conductor are equispaced, that is uniformly spaced. So what happens? It's a good example of good distribution of the touch potential. Now you will see in terms of color coding. So all the red and yellow are vanished over here. Only blue and sky blue and green colors are available on the particular site. So it's proper representation of, properly distribution of touch potential on the ground of 3D plot with a spaced grid conductor, that is uniformly spaced grid conductors. Why I'm adding these slides? Because in the design, there is only one line that the conductor should be equispaced. So why it should be equispaced? So this is the reason. If we space the conductor equispaced, so what happens? There is a proper and uniform potential sharing between these electrodes. As we see in the case, in the earlier case, there is a non-uniform sharing of the potential. Now here it is a uniform sharing of the potential, and we are able to reduce the surface potential of this particular earth mesh. Here, the earth mesh surface potential is very much higher, even though the earthing is installed, but the conductors are non-uniformly spaced. Here, the earthing potential we are able to minimize because the earthing is installed, but it is installed with uniformly spaced conductors, which is very much visual with the color codings. As on the right on the color screen, you will able to see the dark blue will be only 30 volts and the red one will be around 700 plus volts. So this will be the potential differences we will feel if we space the conductor equispaced. Now we'll move ahead. Now coming to a very important thing, that is practical approach to SNT, that is step and touch potentials. As we know, in the substations, we are able to maintain the step and touch potential because we are already maintaining the earthing. So how do we maintaining the earthing? We are making the maintenance of earthing, watering, and we are yearly we are taking earthing values, making a corrective action and all. So we are very much aware that our substation earthing is in proper way. So we are able to work with good confidence on that particular earthing area. But while working on the transmission tower lines, so that tower line earthing maintenance is not that much as feasible, possible, and easy as we are having in the case of EHV substations. Because as we know, our transmission lines are running throughout the tail end of the districts. Sometimes it is running on the outside of the cities. Sometimes it is running in the valleys. So it is very much cumbersome to maintain proper earthing of a particular tower. And what if we are much aware about that the earthing is proper, but what happens if earthing is not proper? Each and every case of emergency, we are not going to test the earthing first and then we will climb on the tower. In the case of emergency, what happens? We will just confirm that the line is dead or not, and we will just try to climb on the particular transmission line. Now you have one question in your mind, that why do we need the touch potential and step potential in terms of transmission line? So there is a reason that now we know there is a good network available among us. So each and individual transmission line, distribution line, HT line, EHV line, UHV lines are crossing each other. So there is a good potential sharing between these two lines in terms of interference, in terms of inductions. And because of these cogeneration lines also, there are good interference in the network also. So what happens? We are not able to identify that this particular tower is properly earthed or not. Only in the case of emergency, I'm highlighting. So for that sake, we are having one solution. That the solution is that SNT meter. So this SNT meter will give us the proper alarming cases of step and touch potential, that you are safe to climb on the tower or this is an unsafe condition to climb on the tower. So this is the case I intentionally added in today's session. This is SNT instrument made from Delta computers. So one more question may strike in your mind, that in the substation we are not checking the earthing, but my dear friends, throughout the year we are maintaining the earthing. But in the transmission sake, it is very much difficult and cumbersome to maintain the earthing, as very frequently we are maintaining in the substation. So something is expected for cross verification of particular tower earthing in the case of emergency, for highlighting the type of tower is safe or unsafe, for in the case of dead case also I'm saying to climb on the tower, it's safe or not. So in the case, we directly go to the site, climb on the tower, and we will come back. But what is the exact procedure for us? We will take a permit from the source end and the load end substation. We'll take a shutdown on the line. The operator will tell us that make a local earthing. Even after a local earthing, many of line people must know that there is a good induction on the line itself. So that induction plus this
we need to
cross-check the condition of the tower is safe or not. So for that, I've added one video, a visual, what exactly this SNT means. So I'm playing the video of SNT, that is step and touch instrument, that monitors and alarms the conditions, which will be a safe condition or unsafe condition. We'll have one visual.
Presenting the Step and Touch instrument from Delta Computer Systems. The SNT instrument protects linemen by continuously monitoring and alarming step potentials and touch potentials caused by ground potential rise. Since 2003, the SNT has kept linemen safe in the Pacific Northwest. This monitoring device comes as a complete kit, including a rugged case, the instrument, grounding rod, 2 different probes, a 15-foot probe cable, and a charger. The SNT is easy to use. Drive the ground rod into a suitable location, use a hot stick to connect the probe to the tower, turn on the SNT, wait for the alarm that indicates the lost probe connection detection is working, slide the SNT onto the stake, and now you can begin your work. When the SNT senses dangerous voltage levels, it will alarm. Yellow LEDs will flash if the potential reaches 100 volts. If it reaches 500 volts, red LEDs will flash. You can silence the audible alarm while you remedy the ground potential rise situation. The visible alarm will continue until the voltage falls to a safe level and you clear the alarm. The SNT design has been guided by lineman requests. Voltages below 10 volts are displayed as 0 in order to avoid nuisance noise. The SNT is not overly sensitive to transients, which reduces the number of false alarms. The probe has a voltage divider in the cable to minimize the chance of high voltages at the meter. The alarm levels are preset so that the lineman can be assured that any meter has the same levels as another meter. However, for special cases, the levels can be factory adjusted. Continuously monitoring step and touch potentials is becoming ever more important as power quarter crowding increases. Electromagnetic coupling from close parallel live lines can result in grounded, de-energized power lines building up dangerous voltage levels. Poor earth grounding situations coupled with changing soil conditions, such as drying during the course of the day, can create a perfect scenario for hazardous step and touch potentials. Keep your linemen safe. Contact Delta Computer Systems for more information.
So this is about the visual regarding the step and touch potential instruments specifically. So in the case, what we see in the visual, that this SNT kits enable us to give an alarm for the voltage ranges from 0 to 100 volt will be the green case. So it will be safe for us to work on the line. So if it is ranging up to 100 up to 499, so it will be alarm state that something is issue with the line and the potential difference is very much high, step and touch potentials. So it will give us a yellow alarm, and in the case of 500 plus voltages, that case, it will give us a red alarm, and that time we must do not allow our linemen to climb on the particular tower. So this will be a local indicating meter for the step and touch potentials, which is very much important in our case. So in the first session, we have seen this earthing prerequisites and its particular case. In the second session, we are going to discuss the design and its aspects. So we will take a 30 minutes of lunch break, and after the 30 minutes, we will have a good discussion on the design. So be in touch in the second session. In the second session, we will be discussing what exactly the design philosophy, designing criteria, one case study, one approved layout from the corporate office, one approved design from the corporate office I'm discussing with you, and the practice, code of practice for the earthing maintenance and proper measurement of earthing, frequency of measurements and details. We'll discuss in the second session. So as of now, so for the first session, if you have any doubt, you are free to ask for the up to the first session only. It's open to you to ask me a question. Is it possible to all participants to open the videos? So we will have one. Yeah, got one question from Jayashree. She's asking, do we use this instrument in MSTCL? Currently, we are not using in MSTCL. Recently, in a few years ago, MSTCL procured this in the demo point of view, but it's not percolated that much as we are expecting, because we are doing proper local earthing. So in that case, we are not going for this SNT equipment. But as of in the line cases, they do having a habit of earthing. One, for example, if you are working on third number of towers, so they are having a habit of earthing of first tower and the fourth tower. So this is not expected. In that case, we do require SNT kit. But while you are working on a third tower, so you do need to earth that particular third working point earthing before and after. That time we do not require this SNT meter. So this will be the case tricky. So we are not that much hand in hand with these SNT meters. So nowadays we are totally running with the proper local earthing at the point of working. So SNT is not in each and every department, but it's available with a few of us because it's procured on demo point of view. But as of the feedback given by the field, so we are not having that much of ample number of quantities available with us. I think, Jayashree, you are satisfied with my answer?